Citrus has been grown in the Central Valley and Southern California for more than a century. In the Central Valley, until about 10 years ago, navel orange groves dominated the landscape in the citrus belt stretching from Madera to Kern County. Now, it seems almost anywhere citrus can be grown in the San Joaquin Valley, healthy plantings of mandarin groves appear where once grapes and tree fruit were planted. High quality and high production are the goals shared by navel and mandarin growers alike. It's up to those managing the crop to make sure those goals are met by each tree getting the optimal amounts of water, nutrients, and protection against pests.
Is there a right way to grow citrus to achieve consistent, bountiful harvests? Top agronomists in both private industry and universities are saying yes, especially when it comes to managing the very important nutrient nitrogen. Of course, proper citrus tree nutrition is complex and involves more than just nitrogen fertilization. Other nutrients, including phosphorus, potassium, calcium, magnesium, and zinc, are also essential and are often applied in high-yielding citrus orchards.
Lately, there's been a lot of attention paid to nitrogen and nitrate, the form that can leach into groundwater. Many groundwater basins in the Central Valley are contaminated with nitrate at levels exceeding safe drinking water standards. The State Water Resources Control Board responded by adopting the nitrate control program that is impacting every industry in California where nitrogen is used as an input or waste discharges contain nitrate.
Testing of groundwater basins in the Central Valley has found that some portion of the contamination is attributable to applications of synthetic nitrogen fertilizers, compost, and animal manures to irrigated cropland. Other nitrate sources are also contributing to groundwater contamination: livestock, wastewater treatment plants for cities, and food processing plants. Agronomists and researchers have devised a management approach for optimizing applications of nitrogen to crops to minimize leaching of excess nitrate while optimizing crop production.
The approach is called the 4Rs: the right rate, time, place, and right source. For citrus, the University of California, with support from the California Department of Food and Agriculture and the California Citrus Research Board, has spent years refining the 4Rs and now has many proven practices ready to be used today in California citrus. Some still need further study and refinement.
Before going into details on the 4Rs, it's important to understand the relationship between soils, nitrogen fertilization, and irrigation practices. In particular, how nitrate moves in the soil, how it is taken up by a tree, essentially how all the science turns into management implications and tools. A fundamental point to remember: in a citrus grove, any source of nitrogen applied as a crop nutrient can convert to nitrate. If conditions are right, nitrate can eventually leach beyond the root zone and into groundwater aquifers.
Other factors are in play with nitrate, such as soil mineralization, losses to the atmosphere, and biological processes. But leaching excess nitrate to groundwater is a major focus these days and deserves much attention. Excess nitrate is defined as nutrients applied that are not taken up by the tree during the active growing season. First, we have to understand why nitrogen is important for plants.
Plants use more nitrogen than any other nutrient. Nitrogen is used in the tree's DNA and in hormones that signal the plant to perform certain functions such as cell division. Nitrogen is also a component of amino acids which are used by the tree to make enzymes which are also important for cell functions. Nitrogen is also critical for chloroplasts, which are the tree's sugar-making factories. When nitrogen is deficient in the tree, it can limit growth and cause leaf chlorosis. More often, we see high nitrogen levels which can cause excessive vegetative growth, especially in young trees. When thinking about nitrogen applications, you want to think about providing just enough to meet your yield demand in mature trees. In young trees, you want good growth, but no extra vigorous growth.
It's important to understand that trees take up nitrogen when they demand it. So, in mature trees with a good crop set, the vast majority of nitrogen goes into the crop and a small amount supports vegetative growth. When planting a new orchard, especially in rich soils, it's important to perform a soil test to ensure that the correct amount is available to the new trees. Under these conditions, additional nitrogen applications may not be needed until the tree starts showing significant growth. Keep in mind that excess nitrogen fertilization can lead to increased disease susceptibilities.
To help understand how to effectively manage nitrogen applications, you need to understand the different forms of nitrogen in the soil and how nitrogen is taken up by the tree. There are basically three forms of nitrogen in the soil: soil organic matter, ammonium, and nitrate. Soil organic matter is the nutrient storage bank in your soil. In the short term, organic matter nitrogen is tied up in big, complex organic molecules that are not immediately available to plants. But over time, this organic matter breaks down and provides a steady supply of ammonium and nitrate to the soil and roots. Ammonium and nitrate are the forms of nitrogen that roots can take up.
Being positively charged, ammonium can stick to soil particles, which are predominantly negatively charged and hence does not leach easily. Nitrate is the other form of nitrogen that roots can take up from the soil. However, unlike ammonium, nitrate is negatively charged, so it cannot stick to the soil particles, making it susceptible to leaching. As a reminder, when we talk about the cation exchange capacity in soils, we mean the ability of a soil to temporarily hold on to a positively charged molecule. Ammonium is one of those positively charged molecules typically found in soil.
How do these forms of nitrogen cycle through different forms in the soil? Let's start with the soil organic matter. As organic matter is broken down by soil microbes, it releases ammonium. In warm, moist soils, this can occur in a matter of weeks to months, while in cold soils below 55 Fahrenheit, this can be a very slow process. The carbon to nitrogen ratio is also critical. The higher the ratio, the slower the breakdown. Because this process is driven by microbial activity in the soil, it's very complex. As with all biological processes, it happens faster when moisture is present, when there is oxygen for microbes to use, when temperatures are warmer, and when organic matter has a lower carbon to nitrogen ratio.
When you apply organic amendments, such as compost, you stimulate microbial activity, and those microbes require nitrogen and carbohydrates, both of which are present in compost. A good rule of thumb is that if the compost is less than 2% nitrogen, any nitrogen is going to be tied up by those microbes for a period of time until those microbes die. So, in organic systems, or if compost is applied as a supplement to conventional fertilizer, it's important to understand the nitrogen content of the compost, since its availability to the plant can be delayed until the compost breaks down.
Once nitrogen is in the ammonium form, it can then turn into nitrate through a process called nitrification. Nitrification is also microbe-driven, so the rate at which this occurs depends primarily on temperature. In California soils, during the growing season, nitrification happens in a matter of days to weeks. As a consequence of this rapid microbial action, the nitrogen in soil organic matter converts to ammonium, which turns into nitrate, where it becomes leachable if it's not taken up by the tree. The same goes for fertilizer urea. It quickly converts to ammonium, then nitrate, which can leach if it is not taken up by the tree.
So how fast does nitrogen in organic matter and ammonium nitrogen turn into nitrate? At 50 degrees Fahrenheit, it takes 4 weeks for 40% of ammonium present to convert into nitrate. At around 60 degrees in the top 2-3 inches of soil, 60% of ammonium that you apply will turn into nitrate in 2 weeks if it's not taken up by the plants. At 75 degrees, it only takes 2 weeks for 100% of the ammonium to turn into nitrate.
Now let's talk about how nitrogen moves in the trees. Nitrogen uptake in trees is regulated by a number of biological factors. One principle to understand is that trees will limit nitrogen uptake when the plant already has all the nitrogen it needs. You can over-apply beyond what is needed, and there may be some uptake. But there is a point of diminishing returns since not all applied will be taken up by the roots. If a tree does have a need for nitrogen, the uptake rate may increase as the applied rate increases, but the tree will eventually reach a plateau and the uptake maxes out. It gets to a bottleneck stage where you can't get more nitrogen into the tree. It's already going as fast as it can.
Translated to a management practice, this means spoon feeding or applying smaller amounts over multiple applications. The more split applications, the better. You have less nitrogen sitting in the soil, waiting to be taken up by the tree and vulnerable to leaching due to an accidental over-irrigation or poor distribution uniformity, leaching nitrates from portions of the field. Which all means that more nitrogen applied does not necessarily mean more nitrogen is taken up, and that it won't increase yields, especially if a tree was already at sufficiency levels.
All of this science about how nitrogen behaves in the soil and in trees must be translated into practices for managing a citrus orchard. Let's start with the right rate. Applying the right rate is about matching nitrogen supply with the nitrogen tree demand. That demand is all of the nutrients a tree needs to build the branches, twigs, leaves, and fruit. Here's our supply side: cover crops, manure, compost, and the nitrate in irrigation water and synthetic nitrogen fertilizers, and even what is already in the tree, especially if there's a history of heavy applications in the past. Some of the nitrogen that isn't used by the tree can cycle in the soil, but generally any excess nitrate is susceptible to leaching into groundwater. Keep in mind that a citrus tree is regulating its nitrogen uptake since there is an energy cost for the tree to take up nitrogen. If we apply more than a tree needs, it won't expend extra energy to take up or incorporate nitrogen that it doesn't need. If we apply too much in a season, or even more than a tree can take up at any time, this can mean that we are spending money we don't need to spend on something the tree has no use for.
Before we go on, let's talk a minute about nitrate in irrigation well water, or as it is being called, pump and fertilize. Years of research has shown that this nitrate is available for plants to absorb and use just like any other source of nitrogen. An inexpensive well test can tell you exactly how much nitrate is in your irrigation water. Here's how Central Valley Water Quality Coalition suggests doing the math. Take the test results, say 15 parts per million, and multiply by 0.226. Each part per million represents 0.226 pounds of nitrogen per acre per inch of irrigation water applied. That equals 3.39 pounds of nitrogen per acre inch of water. If you apply 36 acre inches or 3 acre feet of water during the growing season, the total is 122 pounds of nitrogen per acre each year. There's one more step. You need to multiply that 122 pounds times the crop nitrogen uptake efficiency. As a rough estimate, let's use 70% efficiency. At 15 parts per million and 70% efficiency, you should include about 85 pounds of nitrogen per acre in your overall nitrogen budget, just from your nitrogen irrigation water. Think of it this way: that's 85 pounds of free nitrogen applied to your crop. Better yet, you are helping clean up the groundwater aquifer.
One caveat: these assumptions don't take into account rainwater included in your crop's annual water account. For example, if only 2.5 acre feet of well water is applied because 6 inches of rain fell during the growing season, that needs to be taken into account in your calculations. So, a key component of the 4 R's is the right amount of nitrogen. The tree takes up nitrogen throughout the growing season, starting at bloom and continuing up to harvest. We want the right amount in the tree, when the tree needs it, and where it can get it.
So how do we arrive at the right rate? Research and field experience has shown that on average, a mature navel orange tree needs about 100 pounds of nitrogen per acre for a crop yield of 25,000 pounds per acre. That includes 80 pounds for fruit development and another 20 pounds per acre for the tree branches and leaves. For mandarins, the amount of nitrogen needed is similar, about 100 pounds per 25,000 pounds of yield per acre. Keep in mind, young citrus trees tend to be alternate bearing and can have production swings from a low of 10,000 pounds to as high as 30,000 pounds per acre of marketable crop. They can also be alternate bearing if they are experiencing stress such as drought or insect damage. So application rates need to be adjusted to account for this yield fluctuation.
New research recently completed by the University of California in Central Valley orchards shows those application rates may need to be adjusted. Work performed by Doug Amaral with the University of California Cooperative Extension found rates to support 25,000 pounds of crop yield per acre are between 32 and 38 pounds of nitrogen per acre. In addition, the trees will need nitrogen to support the tree growth. An orchard with 200 trees per acre will need about 30 pounds more of nitrogen for that canopy and trunk development. These rates assume 100% nitrogen uptake efficiency. In 2017, a 3-year research project funded by the California Department of Food and Agriculture focused on studying nitrogen uptake in citrus in the Central Valley. Publication of the study results is expected in late 2024. The fieldwork was done in Fresno, Tulare, and Kern counties. Samples were taken from 27 trees in navel orange and mandarin orchards throughout the growing season. Nitrogen content was analyzed in the roots, trunk, scaffolds, canopy, branches, leaves, and fruit. These samples were collected at pre-bloom, bloom, fruit set, cell enlargement, fruit maturation, and pre-harvest. The results showed that 1.3 pounds of nitrogen for mandarins and 1.5 pounds of nitrogen for oranges was removed in every 1,000 pounds of marketable yield. Based on this study, our right rate for a mature citrus orchard is about 1.3 pounds for mandarins and 1.5 pounds for oranges per 1,000 pounds of fruit yield. For a mature orchard, add another 0.15 pounds per tree to compensate for tree growth, such as trunk, branch, and leaf development. In addition to calculating the right rate, it is equally important to make frequent applications in smaller amounts to reduce the risk of leaching. The typical 3 to 4 nitrogen applications in a growing season can result in temporarily high soil nitrogen, leaving it prone to leaching in a subsequent irrigation or rainfall event.
Ideally, nitrogen fertilizers are spoon-fed over multiple injections during the growing season. Additionally, nitrogen uptake and nitrogen use efficiency can be greatly hindered if growing conditions are not ideal, or if there are deficiencies in the other macronutrients such as potassium and phosphorus, or micronutrients such as iron, zinc, and magnesium. So, if unsure, performing a soil analysis periodically can provide the best information for designing a nutrient program to maximize production and minimize any excess nutrient applications.
One of the best tools to guide your decisions on the right amount is through leaf analysis. Leaf sampling results can provide valuable information to help you design a rational, plant-based fertilization regime. Citrus growers have been using leaf nutrient analysis for more than 40 years to check for tree nitrogen status, typically taking leaf samples in September or October. For most varieties, that's usually too late to make any substantial adjustments in nitrogen applications before the crop matures. The University of California recently completed supporting research showing that nitrate accumulation in citrus was rapid until the end of June. Leaf sampling in July allows for predicting with a good degree of accuracy what nitrogen leaf tissue levels will be in September. Having the results early enables growers to react quickly by either holding off additional applications if nitrogen levels are adequate, or adding fertilizer if a deficiency is apparent.
Leaf sampling can be easily done following a few simple steps. For the early leaf sampling between 30 and 45 days after full bloom, find a healthy shoot that does not have any buds. That's called a non-fruiting shoot. Find a leaf that is in the sunlight at least part of the day. When collecting the leaf samples, think of your tree as a pie split into 4 quarters. Collect 1 terminal leaf per quarter for a total of 4 subterminal leaflets per tree. Choose leaves that are 3 to 5 feet above the ground. Select trees in a diagonal or U-shaped pattern, excluding border trees, and from a minimum of 13 trees per orchard block, if soils and tree growth are fairly uniform. If there are dramatically different soil types, subdivide the orchard into blocks based on the soil type and take leaf samples from each area. Put all your leaflets from each orchard block into separate paper bags, mix them well, label the bag with an orchard identification, and send them to your nutrient analysis lab of choice as quickly as possible. If temperatures are warm, keep the leaf samples in an ice chest. It's best to get a full leaf tissue analysis, not just nitrogen. Instruct the lab to analyze for nitrogen and also the other key elements of phosphorus, potassium, calcium, and magnesium.
Results from all these nutrients in combination will better guide recommendations if changes in applications are needed. If using July leaf samples, remember that wild citrus trees generally respond with more crop and vigor when more nitrogen is applied until about 2.4% leaf nitrogen. Beyond 2.6% leaf nitrogen, we don't see much value. There aren't increased yields beyond that level, nor is there increased tree health. In fact, beyond 2.8%, there are negative impacts such as too much vegetative growth. The ideal range is 2.4 and 2.6% leaf nitrogen. Leaf sampling results can help fine-tune your nitrogen management strategy to better match yield estimates with actual production potential.
Now let's talk about the right time. Keep in mind that a tree has biological bottlenecks called transporters that control nitrogen uptake in the roots, preventing uptake if there is no tree demand. Applying at the right time is about matching the timing of the tree demand with the root uptake. When is too early to begin applying nitrogen? In a mature citrus tree, the demand for nitrogen is high from early spring, usually March, when shoot growth and fruit development commence, and will continue through August once fruit reaches the full size. This uptake coincides with vegetative growth and decreases during fruit maturation. We also know that 80 to 90% of the total nitrogen is accumulated by September in both orange and mandarin species. So it's not worth applying nitrogen before the new leaf flushes because roots are not yet taking up the nutrient, leaving the nitrogen to be potentially leached by rain or irrigation. The same can be said for applying nitrogen in September or later when uptake diminishes to essentially zero.
So where is the right place to apply nitrogen fertilizers? Applying it in the right place means knowing where the majority of roots are located and applying nitrogen where roots can best take up both nutrients and water. Typically, the vast majority of important feeder roots are in the top 2 feet of soil. Citrus can actually send roots several yards deep to take up water, but it's uncertain whether these roots can take up nitrogen. Roots will be shallower in young trees, but root depth will change as the tree grows. So it's in that upper 2 feet zone where you want to keep your water and nutrient applications. And remember, nitrate moves with water. So if you push water below the root zone, you risk pushing nutrients below the root zone as well. Active roots will always be in the same location that irrigation water is applied. In old flood irrigated orchards, roots probably look like what you think of them when you think of a tree root systems. Spread out, exploring a very large area. Root distribution in an orchard can vary dramatically if you compare tree-to-tree sprinklers and flood irrigation to high-efficiency systems, such as micro sprinklers or double-line drip. However, it's important to remember that they will be concentrated where the water is applied. That is why fertigation, injecting fertilizer during irrigations, is the most efficient method when using high-efficiency systems. With fertigation, all the nitrogen is directly applied to an area with the highest concentration of active roots. And speaking of fertigation, always inject the fertilizer at the last half or quarter of an irrigation set. That way the fertilizer isn't pushed past the root zone. Then stop the injection 10 to 15 minutes before the set is finished to ensure the system is adequately flushed. This is especially important when growing citrus in soils with high salts where a leaching fraction is needed.
As for the right source of nitrogen, there is no indication that the form or type applied will impact yield or tree growth. However, the short-term leaching potential can vary. Ammonium is a positively charged form of nitrogen and will not initially leach. However, soil microorganisms rapidly convert ammonium nitrate to nitrate nitrogen when soils are warm and moist. During the growing season, it can take only 1 week before 100% of ammonium nitrate is converted to nitrate nitrogen, and nitrate nitrogen is leachable. Again, nitrate is negatively charged and can move through the soil very easily, so keep that in mind when choosing nitrogen fertilizers and managing that fertilizer application. There's a lot that goes into selecting the right source. In particular, how much do you want to spend per acre? What application method is used, foliar or fertigation through sprinklers or drip? There are many nitrogen fertilizer product options, but each has its own baggage.
When choosing a commercial nitrogen fertilizer, consider how much and when the nitrogen is available for plant uptake. Calcium nitrate is a readily available form of nitrogen, but also has a high leaching potential. This leaching potential can be managed with well-timed applications, and calcium nitrate is well suited to fertigation systems. The calcium in the calcium nitrate can also be helpful for managing soil salinity. Urea ammonium nitrate, UAN, is very popular due to its solubility. The mixture of nitrate forms makes this a slightly less leachable form of nitrogen, although in warm spring and summer conditions the conversion to nitrate is very rapid, especially in California. Additionally, urea is very leachable until it is converted into ammonium. An additional consideration is whether these fertilizers will acidify the root zone.
Ammonium and ammonium-creating fertilizers will decrease soil pH. This can be a good thing if you are growing an orchard in an area with high pH, high free lime, and/or sodic conditions. It can be a bad thing if you are growing an orchard in a light-textured soil that has a low ability to buffer pH changes. When applying compost or manure, remember that these materials need time to mineralize and convert to ammonium, making it plant available. Some of this can be measured in years. The release rate depends on how it is incorporated, the carbon to nitrogen ratio, and other factors. A good information source on compost is available on the UC website.
Some agronomists estimate that about 40% of nitrogen applied as compost is available in the first year after application, another 30% the following year, then the balance is released across several years. Research performed by the University of California suggests that there can be a significant variability in those estimates depending on many factors including compost sources, temperature, soil types, and other factors. As for nitrogen content, compost averages about 3 to 4%. So if you apply 4 tons per acre, nitrogen available the first year would be about 96 pounds per acre. And remember, availability of nitrogen from compost is very temperature dependent. There are many factors related to fertilizer options, but always keep in mind the vulnerability inherent with each choice.
Finally, let's pull together a right rate, time, place, and source into one calculation.
To determine the right rate, estimate how much nitrogen needs to be taken up by the tree in order to develop the estimated fruit set. To do this, we need to account for both our yield potential and crop nitrogen uptake efficiency. First, to develop a realistic yield potential, we should consider the yield history of each orchard and compare it to the current year growing conditions and conditions during and after bloom. Let's say, based on previous years, we expect a 25,000 pound marketable crop yield per acre. Next, let's consider the crop uptake efficiency, which can be influenced by your irrigation system. The timing and precision of your applications all influence the efficiency with which applied nitrogen can be used by the tree. Typically, growers can be as low as 50% efficient and as high as 80% efficiency. To apply this calculation for your production, adjust the multiplication factor by the number of 1,000 pounds weight of your anticipated yield. If the projected yield for a navel orange orchard is 25,000 pounds of marketable yield, then first we multiply 25 by 1.5 pounds of nitrogen removed. This equals 37.5 pounds of nitrogen. Next, we need to multiply the number of trees in this orchard by 0.15 pounds, which is needed to cover tree growth. In this example, let's assume 200 trees per acre. This yields 30 pounds of tree growth nitrogen. The sum of our two calculations results in 67.5 pounds of nitrogen demand. Don't forget to take into account the nitrate in your irrigation water. You will want to subtract any nitrogen that comes from irrigation water or compost applications. Then multiply this amount by the nitrogen use efficiency factor of your field. In this example, assuming a 50% efficiency, the application rate would be 135 pounds of nitrogen per acre. An 80% efficiency would require only 84.4 pounds of nitrogen per acre. That's our rate. Low efficiency costs you real money and can leach large amounts of nitrate.
Then we get into the right time. We know that growing fruit is where the vast majority of the nitrogen goes. So we're looking at even applications commencing in April through August or September, depending on the cultivar you're growing. Next, let's identify the right place. For citrus, this is the upper zone where the roots can take up the nitrogen. So we will manage our irrigation to keep most of our water in the top 2 feet of the soil profile. Finally, our right source. Keep in mind that various sources have differing leachability levels that will impede nitrogen uptake.
Here's a summary of the takeaways from this session. 84.4 to 135 pounds of nitrogen for every 25,000 pounds of navel orange fruit per acre, depending on your irrigation and uptake efficiency. Don't apply more nitrogen than the plant is using. Too much nitrogen will decrease the fruit yield of the trees. Spoon feed the trees throughout the season. Inject nitrogen fertilizer in the last quarter of an irrigation set, stopping the injection from last 15 minutes of operation to flush the system.
Following these steps will go a long way toward increasing your nitrogen use efficiency and decreasing nitrate leaching to groundwater. Best of all, ensures you get the most value from an expensive crop input. And in this farming economy, we all want the best return on every dollar invested.